Howdy, this is Adrian with Pulaski Technical College, the Weatherization Training Center. We're going to go through a module called Inspector's Toolbox. By the end of this, hopefully, you're going to be able to identify what an inspector needs, what's necessary, what kind of tools, equipment, and their usage that an inspector ought to carry with them, have available to them when taking a look at a home to close it out or to judge the work that's been done on it, and then also to explain the various tools used by the inspectors and their purpose. Why do we carry what we carry? Why don't we carry something else? Well, we've got reasons for that. We're just going to give you the basics here. We're not going to go too deeply into it. But we're also going to discuss the importance of following the manufacturer's instruction for care and maintenance, especially for calibration and things like this, because we are depending on these tools to tell us how good of a job we are doing. So we need to follow what the manufacturer says about their use. So here we have a photo of some various hand tools, and clockwise from the lower left we have a telescopic ladder here. This can fold down and be very, very compact. We do want to make sure that if at all possible, this be OSHA compliant. We need to use this to get into scuttle holes, etc. It's pretty lightweight, easy to maneuver in tight spaces. You don't tear a homeowner's home up too much. Above it we have a Phillips screwdriver and some side cutting pliers, a slotted screwdriver, a crescent wrench or an adjustable wrench if you will, a razor knife, a 25-foot tape measure, a good flashlight, a good digital camera, and pencil and paper, and then something that's right here in the middle of this screen. This is a crochet hook, and this is used to get into those tight areas and pull out a sample of insulation so we can see what type of insulation is being found in that wall. Okay. We have some other, these are more specialized tools. We have various prying tools, pry bars and nail pullers. We have a cordless drill driver with adequate batteries and a good selection of tips. We have a good drill index. Now this is, I would recommend that you get the type that when you look at this portion, the metal section there that tells you what size it is, you also have something that gives you a decimal number, you know, like a 0.41. That will be the equivalent of a orifice size. So we can check orifice sizes with this drill index on gas equipment as well. Okay, so we have a nail puller here. It is what we're going to use it for. That's not what it really is. What it really is they're nippers, and we're going to come in here in this area right in here between the two blades and grind some of the sharpness off of that. The reason for that is so that we can pull nails with it as opposed to cutting the heads off of them. Great siding removal tool. And then we have various hand tools within here. We've got a good framing hammer. Sometimes you really need to smack something hard. We have some locking pliers. You may know them as Vice Grip brand. A very long reach screwdriver, long reach needle nose pliers, and then we have a reamer to enlarge the smoke hole when we're testing a heating appliance efficiencies. A square bit screwdriver. Sometimes that's really helpful on mobile home siding, and then a star bit screwdriver again for mobile home siding. You may also want to get a clutch head screwdriver. That's available from some of the mobile home specialty places like Blevins. I think they carry a clutch drive screwdriver. In your tool case, you should have things laid out and organized. Everything should have a place and everything should be in its place. You should understand what it looks like because when it comes time to go, you want to be able to tell that you have everything with you and be able to find it when you need it. Now, things that help you see a little bit better are a good digital camera. This is a Sony brand. I don't know why they're recommending that, but any good brand of digital camera will work. And I don't recommend spending a whole lot of money on these. You're probably going to beat the heck out of them and use the heck out of them. They'll probably need to be replaced about once a year. Keep the SD cards in them. When they quit working, throw them away, get a new one. But get a decent one. Get one that's easy to use, one that you can pull the SD card out of and put it into a computer and have it read it so you can transfer data from it easily. Now this thing up in the top right hand corner, this is a borescope, and this is a purely mechanical borescope. This one is all line of sight. It does change the sight direction just a little bit, but for the most part, this is an old-fashioned borescope. We have some newer electronic styles that will display to a screen. The Testo Video Pro is a very good example, but they're not the only ones that make them. Intech, FLIR, General Tools all make a decent borescope. And speaking of FLIR, how about infrared? FLIR is pretty much known for infrared, but you can go with Fluke, X-Tech. It doesn't matter what brand you go with. What's really important is that you get one that you can use and you understand how to use it, and that it's robust enough. You can get replacement parts for it. I wouldn't spend too much money. The one that's shown here, that FLIR, is a very expensive unit. The Fluke, we've got a couple of those and we're happy with them. We've got some FLIRs, we're happy with those too. I don't make any recommendations on them other than don't go too cheap. You want to be able to get something that you can adjust. If you have more questions about that, you can get in touch with us and we can make some recommendations on some of the options to look for. But a lot of them are becoming more and more adjustable at the lower end of the price range. However, there are also a lot of fixed ones that are fully automatic. I don't recommend those. Running them in full automatic until you get accustomed to them is okay, but once you're accustomed to them, you want to be able to adjust settings on them. But infrared allows you to see things that you normally would not be able to see, because it's letting us see in a part of the light spectrum that our vision can't detect. So here on this right-hand picture, for instance, in the top one, when we look at just a regular visible light picture, we are seeing the inside of a bedroom. Looks like a dormer, that's popped out there on the left with a dresser underneath it. But when we look at it in conjunction with the blower door under infrared, what we are seeing is streaking caused by the temperature change of the sheetrock, the surface of the sheetrock, and that's caused by air either moving over it or, in this case, I would suspect behind it. Now notice how I'm saying I would suspect. I'm a level 1 thermographer, but even at that, I'm not going to make assumptions and say, well, that's what this is. Because until we test, we don't know. We can just see and then interpret what we see. That's the biggest thing with infrared. Always remember that it's always an interpretation of what you're seeing. It's not a hard, fast rule. Those black streaks there, in my mind, warrant a lot of investigation. We need to figure out why we have that. Get into that attic section, that sidewall attic over there, and figure out that side attic, and find out why we have apparent air movement there and confirm it with smoke or something else. And then when it comes to combustion equipment, we want to have a good combustion analyzer. Now there are a lot of good ones. You can go from a very basic like this Bacharach FireRite Pro, which has been around for a long time. It's still available. The Bacharach Insight, and they're making a couple of models of those. And then the Testo over here is another really good example of a very powerful, this 327 is a very powerful and capable instrument, and so is the Insight. I'm not going to recommend one over the other, but even at that, the Bacharach FireRite Pro will do a very good job. The biggest thing here that you want to do is make sure that you get one that has 2 sensors in it that can detect 2 types of gases, preferably oxygen and CO. I'm not going to get too deep into it, but some of the other brands, they may or may not be giving you as accurate a reading as possible. It has to do with this stoichiometric equation that they're using. They know better. I'll just say that I prefer one that reads CO or that has a CO sensor and an oxygen sensor, as opposed to an oxygen or to a CO2 sensor and an oxygen sensor. That's just my preference. Okay, and then you've got a combustion appliance test kit. Now this should contain a lot of things. If you do fuel oil at all, or solid fuels, well, probably just fuel oil, you're going to have a smoke pump. And what this does is allow you to take a sample of the exhaust gas and start to determine whether or not it's safe to put your combustion analyzer in it. Fuel oil burns with a lot of particulate, or can burn with a lot of particles in the exhaust, and those tend to clog or damage your sensor very, very quickly. So you can take a $100 or $150 sensor and clog it up. It may have almost zero life left after that. That's why you take a sample with the smoke pump until the unit has been. Take a sample, and if it's at a certain level or below, then it's safe to put your combustion analyzer in it. It won't soot it up too bad. If it is higher than that number, at that point you're going to have somebody qualified to tune the equipment up until it passes a smoke pump test. And at that point, then you can put your combustion analyzer in it and see what it's really doing. If you put it in there beforehand, you're risking damaging your combustion analyzer. You want a lighter, a long reach lighter. In this case, we're showing one that's long enough to reach back and get a pilot, possibly on a water heater. The other thing that you want to have is, of course, the combustion analyzer and the manual. Carry the owner's manual with it, so you know what you're doing in case you have to change batteries and reset up some parameters. Carry some high temperature sealant. That's what's in this red tube right here. This is high temperature RTV silicone, and it's an automotive style product. It's fine as long as it meets the ASTM number set out in Appendix A for air sealing, okay, for air sealing. And then appropriate drill bits for the test holes that you're going to drill. In addition, depending on what your agency, what you folks are allowed to do, some places you have to be qualified by license or registration in order to work on heating equipment or gas lines. In other places you do not. But I'm just going to show you the equipment and assume that you're capable of using this. Not only physically do you have the education, but also the licensure to do this. So here on the left we have a mechanical, or an analog rather, thermostat. We also have an analog draft gauge, and then an inspection mirror. In this case it's stainless steel. On the right hand picture we have some pipe wrenches, a combustion analyzer, a gas leak detector, very important for gas fuels. We have another inspection mirror, some leak detection bubbles, and you may not be able to see those real well, but there they are. This type uses a dauber. I kind of like it. If you can get close enough to it. I also carry the spray style. I prefer to have both of them. And then a smoke pump and your smoke test filter paper. You need to use what the manufacturer suggests. And then, of course, we mentioned the combustion analyzer. You want to have a good combustion analyzer. When we're testing cook stoves, a single-purpose instrument like a monoxer is pretty good, but it's only good at measuring CO in ambient air. And what I mean by ambient air is the air around us, or just a particular sample. Okay. When you take a piece of flue and concentrate the exhaust gases so they're not mixing too much with the ambient air around it. Now look at the bottom of this picture. Here they have not cut off their secondary combustion air. If you were to take this piece of pipe and make it out of something that was too large so that it sat down on the porcelain, sat down flat on the porcelain of this cook stove, it would be cutting off the secondary combustion air, and you would not be getting a proper reading from this burner. So using a smaller section of stove pipe, probably 5 inches or less, possibly up to 6, depends on the burner that you're going to put it on, is a good idea. But here we've just taken a piece of single wall and we have modified it with just some bent angle and some screws. Now the probe here goes in, and at some point it's probably passing through an eye bolt, okay, to support it, so that you can stick your probe in there and the probe can tip and catch against that, and the probe's not heavy. You don't have to sit there and hold it, in other words, hold the probe, which can be difficult, and you'll get a good concentration of exhaust gas to check it. Okay. Generally we recommend remedial action anything above 25, and for sure over 100 we would have to take some other actions depending on what BPI standards are at the time. Okay. But always follow the manufacturer's instructions for the stove. for routine care and maintenance. They may at that point call for a cleaning or something like that. Okay. Taking care of your equipment, especially combustion equipment, can be a little bit of a pain. If you don't know how often to calibrate it, the manufacturer doesn't say. Some of them need to be calibrated every 6 months. They need to have the oxygen sensor replaced every 1 to 2 years. Once the oxygen sensor, they're shipped in sealed packages generally if they're replaceable, if they're field replaceable. But if they're not, if the unit has been exposed, if that sensor has been opened and exposed to air for a year or two, it becomes saturated even when the unit is not running. It's still coming in contact with oxygen. The reactive surface of that is degrading, which means that you're going to need a new oxygen sensor in a year or two, even if the instrument hasn't been used much. Carbon monoxide detectors follow the manufacturer's instructions. They may need to be calibrated to the outside air so that they're reading a delta, a difference between the inside and the outside. Some of the personal CO detectors are absolute CO detectors. They will tell you how many parts per million are in the air. They don't need to be calibrated to the outside air. Follow the manufacturer's directions. Usually a monoxer should be calibrated to the outside air, and most combustion analyzers should be calibrated to the outside air. And again, the CO sensors should be replaced on a regular schedule. Check with the manufacturer to see what that is. Gas leak detectors, you want to test with the gas from a cigarette lighter. And what they're talking about there is if you have an old-fashioned cigarette lighter, which I happen to have. Nope, I don't. But one that burns this stuff right here, okay, a lighter fluid. Gas leak detectors will detect almost anything that is combustible, including lighter fluid. So that's a good way to test it. The thing that you need to be careful of is the glycerins that you wash your hands with, or sanitizers, anything you get on your hands, lotions. They may also contain volatile organic compounds, which can set the gas leak detector off. So if that's the sensor, if this is where my gas leak detector sniffs from, I don't want to grab it like this. I don't want to put my fingers near the tip. I want to hold it back a few inches at a minimum, okay? Preferably just hold it by the instrument head itself and not by the wand at all, okay? All right, your blower door. Blower door is pretty ubiquitous today. Everybody seems to use them. You definitely need to have one. I would carry a spare manometer if you have some older manometers. Carry it. If not, at least get something to split the reference on it, a T with some extra hose and lots of extra hose so that you can run testing throughout the house. But don't be afraid to take your manometer off the blower door. Once you get the speed stabilized and you know that you're running at about minus 50 Pascal, you can pull the manometer off and disconnect it from the blower door and go on about your business with the manometer. Don't be afraid to do that, but having a spare manometer sometimes really helps. Then you want something to create smoke. You want to carry something so that you can make some smoke. Now some folks love these things and some folks hate these things. They are a non-toxic smoke generator, meaning that the smoke that they create is non-toxic. Some of the older puff ones use a chemical that is truly, what do you want to call it? It's buoyantly neutral in air. It has about the same, it won't rise or fall because it's the same temperature as the air. So it will move with the air. Whatever air you put it into, if that air is moving up, it's going to move with it. If that air is moving down, it's going to move with it. It's not going to rise or fall on its own. Whereas these smoke generators tend to generate with heat. You're looking at a combustion byproduct there, and so the smoke tends to rise almost no matter what's happening unless it gets in a stronger airstream. But that's not really a bad thing because we are using a pretty good airstream, or we're looking for a pretty strong airstream anyway. All right, So your blower door, you need to check your fan housing on it, make sure that they are not cracked or bent. I have seen them bent. The fan housing is calibrated, meaning that it is designed to a specific shape and size. And if you've got a dent or a crack in it, then that changes that calibration. So make sure you don't have any problems. If you think you've got a fan that's not good, well, test it against a fan that you know is good. If you've got a fairly new blower door, test that older fan against it. Run a blower door test on the house and come back and change the fans out and run it again. And in the same configuration, you should get numbers that are extremely close to each other. If they're differing too much, send that fan in for replacement or calibration. All right, manometers. There are several more manometers available than just these two, but these are probably the two most popular, the DG700 from the Energy Conservatory and then the DM2 from Retrotech. They're both very good manometers. We use them to measure leakage rate on the shell. We use them to measure draft. We use them to measure duct leakage and fan flow rates and zonal pressure differences and all kinds of things. This is the backbone of what we do as far as diagnostics go. If you don't have a good manometer, you're just guessing. And guessing when it comes to testing is not a good thing. It doesn't tell us anything. I guess you're right or I guess you're wrong. Either way, I'm right. Okay, because you're either going to be right or wrong. But if we test, then we'll know. Now, this is another good example of an older gauge. I think this is a DG3. And the difference between the DG3 here, oops, come back. Got away from me. Okay. The difference with a DG3 here is it only had one display. So in order to take a look at what was going on with it, you had to flip a switch, tell it to read channel A or channel B. These are pretty good instruments. There's nothing wrong with them. As a matter of fact, really the only difference between these and a DG700 as far as the equipment that's in them, as far as I know, the sensors are fairly much the same. It is just the switches and the controls and then the display and the software to run all of that that's been changed out. But as far as what's actually seeing and generating the signal for the little computer in there to use, it's the same. Somebody correct me if I'm wrong, but my point is this is still a perfectly good manometer. If you're concerned about the calibration, do a field check on it. If not, send it in to the manufacturer and see what they say. Okay. Now, what do we use manometers for? Well, pressure pen tests are probably one of the most often run tests. And we like them because it's very quick feedback on duct sealing. If we seal a run of ducts, we can put a blower door up and go run pressure pan and see how we've done. Pressure pan is also really good on helping to locate the area that we need to pay attention to as far as duct leakage goes on the supply side. If we're getting a big number, we know we're getting closer. If the number keeps getting larger, we know we're probably getting closer to it. That saves work. We can start right there where the big numbers are, spend our money on the big numbers, bring those numbers back down to something reasonable, and then move on to another project if they get in the right neighborhood. You don't have to buy one that's fancy like this one. It's made by the Energy Conservatory, the same people that make the Minneapolis blower door and that gauge on the left. You can use a cake pan with a pressure tap in it. Basically just a hole to stick a hose in. Just make sure the hole is airtight, that you put some weather stripping around it, put some kind of handle on it. Here they've got just a metal stick on it. Okay. Let's look at the next one here. All right, duct blowers. Duct blowers test duct leakage a lot more accurately than pressure pans. As a matter of fact, pressure pans don't test duct leakage. What they're actually testing is for a path. They're testing air barriers, and if the duct has one good air barrier, which it should, then it will test at 0. There will be no difference between what's in the duct and what's outside the duct, which is what we're comparing. However, if we have a bad air barrier, which would be a hole in the duct, then and that hole goes to the outside, then we're going to see a pressure difference. However, duct blowers actually test, put air into and test, bring it up to a test pressure, and hold it there, and then decide how much air it's taking in addition to holding at that pressure. What am I trying to say? In other words, it can quantify leakage for us. is what it does. It actually quantifies. Whereas a pressure pan just says, yes, there's leakage and it's bigger or smaller. It's kind of like playing the game hot or cold. You know, you're getting warmer, you're getting warmer, you're getting colder, you're getting colder. That's a pressure pan. However, this, a duct blower, is a very accurate way of measuring ducts. Normally we want to measure total leakage to the outdoors. Some agencies don't use both. Some agencies do use both. Some use one or the other. If your agency doesn't use a duct blower, that's okay too. If you're in a program that does use a duct blower, you're probably measuring total leakage to the outside. If you're using neat, that's the probably a preferred way to test ducts. And do your agency and yourself a favor. Start testing those ducts if you're running neat, because there's a lot more dollars available with an accurate test on a duct blower than there is with a pressure pan. Zonal pressure diagnostics. This is when we're testing an air barrier. We're conducting a pressure test from one side of an air barrier to the other. And generally the manometer stays on one side and we put the reference to the other side, or we put the input to the other side. It just depends on what's going on in the house. But really it tells us what kind of condition the air barrier is in. The reason we do this is so that we know whether the air barrier is where we expect it to be, or does it appear to be someplace else, or do we have multiple air barriers. A poorly ventilated attic, or an attic with almost no ventilation, will test almost the same as the house in some cases on very small houses. So when you pull the blower door down, pull the house down to -50 with a blower door, you may see -30, -40 in the attic, and you shouldn't be seeing that. You should be seeing, you may be seeing only -12 in the attic when you compare it to the inside of the house. That's only 12 Pascal difference between the attic and the house. What does that mean? Well, air is being pulled out of that attic at a high rate into the house. You want to see 50 Pascal when you test that attic. Okay. The other place we need to use it for ASHRAE 62.2/2010, we have to air seal between attached garages in the house. We have to. It's not an option. That means that we have to prove that we don't have air movement from that garage into the house. Another good place for this is on the exterior water heater rooms on mobile homes. We need to make sure that when we air seal the mobile home that we don't have communication between that closet and the main part of the house. So we put a blower door to depressurize that and go to see if that room is being depressurized at all. If it is, we've got a bad air barrier and we need to do some work. And I hate to do it because those are some pretty tight places. So zonal pressure diagnostics let us see when we have bad areas. This illustration is a 2-story balloon frame, and we are seeing lots of areas where air can move. This intersection right here, this intersection right here, this intersection right here, all of these are places where air can get in. If we have a porch that's attached to the house, generally that does not have any kind of siding or air barrier. The insulation is not going to work as effectively, especially if that's a vented porch. Air is going to move in there and the stack effect is going to take over, and we're going to have air move in through the ventilation at the soffit and right up that wall and into the attic. And that's going to cause this wall right here, this room, to be thermally or radiantly coupled to that wall. So it will always feel warmer or feel colder when an occupant is in there, and it'll probably be a room that's harder to heat or cool. What we're showing here on the graphic is that we're depressurizing this house to 50 Pascal. And the house it hasn't been sealed, it hasn't been insulated, and we're seeing lots and lots of connections, air connections, paths for air to move. So when we start defining the thermal boundary, trying to decide what should be inside and what should be outside, we need to talk about where our air barrier is and where we want to move it and whether it's in the right spot. So if the zones are not where they're supposed to be, we want to start sealing holes on the inside and on the outside, and then start noticing how that affects our pressure difference. Okay. As we move along, we can see how good a job we happen to be doing. So here we've got a home that's sealed and insulated, and you can see, compared to the previous slide, that we're getting some pretty good numbers on the manometer. We're showing a 50 Pascal difference between the porch, that interstitial or intermediate area in the porch, and that's this right here, okay? as compared to the inside. We're seeing 50 pascal difference. That's what we would expect to see. That's what our blower door is showing us. The manometer there is showing us 50 pascal difference. That's how we know we've pulled the house down to 50 pascal. But this one up here, upstairs, is showing a 0 pascal difference. Well, that's what we would expect to see. That's an interior wall. If it has connections from one room to the other through that wall, that's okay. But it should be pulling down or should not be being pulled down at all. It should be at the same pressure as the house, whatever the house pressure is. Okay. So exhaust fan flow. This is something new that ASHRAE standards that DOE have adopted are causing us to do. We need to have something that looks very much like a pressure pan, except it has a big hole in it. It has a calibrated hole right here, and that hole has a shutter or a slide in it. So you've got a hole, and we can start closing off parts of that hole. We've got 3 positions, I think, on it. You can connect it to a manometer. And then on the other side of it, which is not shown in these pictures, there's a chart. So you connect it up, and we'll have a demo of that video of how to use one of these. There's just a few little things that you have to remember when you use this. But once you do, it's pretty easy to use. It's basically just a calibrated pressure pan with a hole in it, and you don't need to use it with a DG700. You can use it with just about any good manometer, but the DG700 does have it built in as or has the exhaust fan flow hood or exhaust fan flow meter built in as a device. I'm going to caution you against using it that way, because hooking it up incorrectly, it's very easy to do. If you do it, make yourself a sticker or something. Tape something on the side of this exhaust flow hood, so that or this exhaust flow meter, so that you know how to hook that manometer up each and every time, or carry something with you, carry the instructions. Otherwise, it's a little easier to ignore the fact that we have a device on there and get a reading directly off this machine and just look it up on the table. Sounds like there would be more room for error, but in my experience, no, there's less room for error. I'll show you in a video some of the hazards of it. It's a good device. You just need to be careful with it. Okay. Your digital manometer, again, it should be calibrated about every 6 months. Return it to the manufacturer, or check it up against another manometer of the same type. You can take this manometer and check it against another manometer. And if you go to the Energy Conservatory's website, they have some field calibration schematics and instructions on their website on how to field calibrate these. It is not the same thing as getting a calibration sticker. It does not do the same function as a true calibration, but what it does is it compares 2 manometers and checks the delta between them to see how far off they are. If they're very, very close to the same within tenths of pascal, I wouldn't worry about it. When they get a little bit more than that, then you need to get to it. I think I will have a copy of that field calibration procedure available up on the LMS, up on Blackboard. Okay. Moisture meters are really good. As we go along, we want to make sure that if we see signs of water or moisture intrusion, that those areas are dry, especially before we do any air sealing. Auditors typically look at moisture and they're only doing a visual observation, but we really need to know whether things are dry or not. We do not want to do things until they're dry. We don't want to seal in or air seal up moisture and trap it. We have a contact and a non-contact type of moisture meter. You've got an electrical connectivity reading between the 2 pins that it's able to do. And the more water that's there, depending on the type of material you're testing, the better conductivity you'll have. Let me see if there's anything else here that I want to say about it. The 2 that we have on the left are pin and non-contact. The one we have on the right, that's really an indoor-outdoor thermometer with a relative humidity gauge built into it, and those are good for reading relative humidity within the house to know whether or not we're doing a good job, such as the air conditioning. If it's cool in the house but the humidity is high, this would show that we have high humidity and give us a number to work with. Telling an HVAC tech that the humidity is high in the house is not as it's not as good as telling them, hey, you know, we're running 80% relative humidity and we're at 68 degrees on the unit. That tells us we've probably got an well oversized unit or some massive air leaks in the house. And then we've got moisture meters. These are another type. Now this one on the left, this one you just lay it down on something. The one on the right is a piercing style. You have non-contact meters that will read moisture levels of the floor framing below the carpet. Okay, all of these are fair. None of them are really great. You can see on the one on the left, it's got 3 different scales right in here. Scale 1 is for wood and timber. Scale 2 is for drywall and roofing. Scale 3 is for plaster and brick. Okay. Sometimes just a pocket knife poking at it and seeing if you're squeezing moisture out on structural framing is a good thing to have. Sling psychrometer, we were talking about measuring indoor relative humidity or relative humidity. Here what we really have, these things look really fancy, but you have a thermometer here and you have another thermometer here. You notice that the bulb on this one, that's what that brown spot is exposed. Okay, this bulb right here has some cotton batting up against it. And the way this is used, the way these are used is you're actually testing 2 temperatures in the house. We put water on the cotton batting, a few drops of water, and then we rotate this at a certain speed. The energy that we put into it by rotating it is forcing evaporation off of the cotton batting. It's absorbing heat in order to evaporate from the thermometer. Okay, so as it absorbs that heat, it drops the temperature reading on the thermometer. The other thermometer can only go as low as air temperature. Okay, so it will stop at air temperature. This other one will stop when we can't put enough energy into it to keep evaporating water off of that wick. The difference between those two, okay, you then take and look on the outside of this thing and read the scale on it, and it says, okay, this is the wet bulb temperature and this is the dry bulb temperature. Once your temperature is stabilized and you've read it, you plot that out and it will tell you, okay, you're about 78% or 68% relative humidity. Sometimes you have to plot it out on a chart to determine it. There are electronic versions of this that are a lot easier. They just read a number to you, or you just read a number off of it rather. Here in the top left-hand corner, we have a non-contact voltage tester. Everybody should be carrying one of these. There is no reason to get shocked by a live wire unless you just didn't see the thing there. You didn't see the wire there. But these live wire testers, you can get them close to an AC circuit, even down as low on some of them, down to 24 or 48 volts, and they'll sing at you. The other thing is a circuit tracer. If we have an issue about whether or not some knob and tube is connected through the wall, sometimes these circuit tracers will help. They also help us identify where to turn off or what to turn off in order to kill a circuit that we suspect is overloaded until we get an electrician out there. Sometimes having a little adapter. This is a lamp base to a 2-prong. Okay, and then this little critter right here, this is really nice because it is a circuit analyzer. You have to use it properly, you have to set it properly, but once you have done that, it is a very good way to tell whether or not you have an overloaded circuit. The problem is you have to use it per the manufacturer's instructions. Don't give up. Read the instructions. If you don't know what you're doing with it, get a licensed electrician out there, somebody who's qualified to test that circuit. But we have to test circuits on under the Weatherization Assistance Program. If we have knob and tube, we have to do a visual verification on it by a qualified person, and there also has to be a load test to make sure that we're not more than 10% of a voltage drop on that particular circuit. Okay, instant read thermometers are really good for testing hot water. To adjust hot water temperature, you want to mark the original position of the dial, verify your water temperature, set it back to about 120. Okay, We're marking the original position in case the client is not happy with the new movement or the new position. I would say, hey, if you're going to move that thing, make sure you set it no higher than 120 degrees. If they want it at 130, set it to 120. Show them where the 130 is approximately. Put a mark on there that you know you put at 120. Take a picture of it and let them move it afterwards. Don't move it back up to 130 for them. From a liability standpoint, either don't touch the thing or set it back to 120. From energy efficiency, 120 is a pretty good place. The reason we're concerned about this is scald injury. It takes minutes at 120 degrees to cause an injury to the skin. However, temperatures above that, you start getting down to the seconds and the even milliseconds at 180 degrees. You have a burn, possible third-degree burn, before your brain even registers that you've touched hot water. So by the time you go, ouch, that's hot, you're already burned. And this is especially true for children under 12 and for seniors that are approximately 60 years old and older. Some seniors get into this issue a little bit beforehand. What it is, at age 12, we grow a layer of fat under our skin. Okay, if you take the skin on the back of your hand and pinch it, some of you older folks, some of you more senior folks, are going to feel that your skin is very thin right there. Some of you folks in your 20s, 30s, and 40s are going to go, yeah, I've got quite a bit of skin right there. Well, it's that layer of fat. That's a small layer of fat that's under our skin. That is what protects us from scald burns as adults. So we can put our hands under water that is too hot and that would burn a small child or a senior, and it wouldn't burn us. So that's one of the reasons that we don't want to get into having water temperatures that are too high. Scald injuries are nasty, nasty injuries. All right, refrigerant testing. If you are allowed to do refrigerant testing, then you should probably have a DOT recovery cylinder for removal. You should probably have a good set of gauges, refrigeration gauges, and you should also have a good digital thermometer with a wet cloth for wet bulb or sling psychrometer for testing to be sure. And this is all at a very, very minimum, okay? And those of you that do HVAC all the time, you're going to go, yeah, add a whole bunch more, like a micron gauge, a vacuum gauge, right, okay? Refrigerant charge testing, I'm not going to get it too deeply into it, but generally on a superheat test, you're going to use this for a fixed orifice or a capillary tube system. Your airflow is going to have to be at least equal to or greater than 400 CFM per ton. Now that is a rule of thumb and I don't like it. However, it's still being used quite a bit in procedural tests, okay? If you don't have the airflow, you're not going to get the superheat that you need, all right? Then you're going to check your charging at a very high outdoor temperature or a not very high outdoor temperature. If you're in Phoenix or something and you guys are seeing temperatures over 100 degrees, that's probably too high, okay? You're not going to do this in a heating climate, all right? And generally, you're going to be an HVAC contractor. But if as a quality control inspector, you should understand whether or not this test is being done at the proper time and under the right conditions. And there are different tests depending on what the valve configuration or your what is this? I can't even remember what the name of the valve is. It's right down here, the expansion valve. Whether you have a thermostatic expansion valve, a capillary tube, a fixed orifice expansion valve, okay? For subcooling, use it for a thermal expansion valve system, all right? Outdoor temperature has to be equal to or greater than 60 degrees. You can't test it too much lower than that. And the air conditioner or heat pump should be running in cooling mode for at least 10 minutes prior to the test. We want that refrigerant to stabilize those temperatures, to stabilize. And subcooling is the temperature difference between the middle of the condenser and the liquid service valve outside. Your superheat is the temperature difference between the evaporator and the compressor inlet. Sometimes people get very mistaken on where to take these temperatures. This is why it's good for a quality control inspector to understand what the test is and how it should be run so that they're not seeing something that is not true when they have an unqualified HVAC person out there messing with the refrigerant. So the refrigerant charge superheat test, we want to use the evaporator superheat test, again, for capillary style or fixed orifice, a capillary tube or fixed orifice expansion valve devices. We have to be running in cooling mode. Okay, we have to have adequate airflow. We need to know what the dry bulb air temperature or temperature of the air entering the outdoor coil is. We need the wet bulb temperature of the return air inlet at the air handler. All right, how many of you are going, all right, stop, just stop right there, you lost me, this is all hurting my head? You're right, it does hurt your head. It's complicated. It's not simple stuff until you've done it a lot. But knowing whether or not, again, this test is being run correctly is key to knowing whether you're getting what you're paying for. Are we testing an air conditioning system and condemning it or passing it because the test was invalid? That's not a good thing to do. So as a quality control inspector, we should understand how things were done. When we start seeing photographs of temperature probes that are either not wet bulb or they are wet bulb being taken at the wrong place, under the wrong conditions, then we can start saying, this isn't right, okay? We want to be careful about calling professionals incompetent. However, we can question them and say, this is my understanding, what is your procedure based on? And then if need be, you know, your state can come back and say, this is the standardized way we're going to do it, or it's always going to be per the manufacturer's instructions, period. A decision would need to be made in that case. Okay, so moving on, you can use the superheat table on the unit to determine a recommended superheat temperature. You want to measure and evaluate compressor suction pressure at the suction service valve and measure and evaluate the suction line temperature. If your superheat temp is too high, you're going to add refrigerant, wait 10 minutes, repeat the test. If it's too low, remove refrigerant, wait 10 minutes, repeat the test. This is if you can't vacuum down the entire system and put it back. If you want complete instructions on this, you can look in the Energy Out West field guide. It's a pretty darn good field guide. I think section 3.8 goes over all this. The refrigerant subcooling test, you're going to use a subcooling test for thermal expansion valves. And if you're greater than 3 degrees more than your target, or you're 3 degrees less than your target, you're either going to remove or add refrigerant to the charge. Okay. Base loads. Base loads are really interesting. These are the things that use electricity that we don't otherwise use for heating or cooling. So this is something that's happening all the time. Things like water heaters and refrigerators. And what really comes in handy are these Watts Up Pro meters and something like a Brultec Kit 60 watt meter. There are several other watt meters, kilowatt hour meters that will do conversions to tell you, you know, how much energy is being used, but the whole point is to measure. We don't want to condemn a refrigerator because it looks old, because we may be looking at a refrigerator that was much more efficient than its contemporaries. We need to follow what is under or in our regulations. Okay. At this point, I'm going to have you folks stop. We're going to go through a class exercise. It's called Tips from the Field. So go ahead and stop this here, and we'll come back in a few minutes and pick up on the next section.